Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet. In this we were doing 3 topics and the pattern was let's solve BFS pattern question. So in the previous video we have learned how we can do binary tree level or traversal using BFS. And now we'll do the next question, which is binary tree zigzag level or traversal. Now what is zigzag level or traversal? Let's see. So here is the problem statement. It says we'll be given the root of the binary tree and we have to return the zigzag level order traversal of its nodes values, not nodes, means we have to print the node values on each level, but in zigzag order. Now let's see what does zigzag mean. It says from left to right, then from right to left. So if you see example number 1, first we will go from left to right. So first we will print 3. Then for the next level we have to come from right side to left side, means we have to print 20 and 9. Then again third level from left to right means 15 and 7. If we talk about constraint, the minimum number of nodes is 0, means we have to write the base case. If root is null, return null. Remember in BFS traversal we solve the question using queue. So hence if the number of nodes can be 0, it is very important to write the base case at first. But if the question says there will be minimum 1 number of node, so no need to write the base case. But in DFS, as it is recursive call, so it is very important to write the base case, whether the minimum number of nodes are 0 or not. And the maximum number of node, it says it can go till 2000. Okay. Node values also from -100 to 100. Why we read the constraint? Because it helps us to understand do we need integer or long format to store the values, or do we need to optimize or not, and so on. And regarding the time and space complexity, we have already discussed in our full YouTube video. I'll attach the link somewhere here, you can check it out. So this is the tree you will be given. Previously we did the level or traversal all from the same direction, left to right. But here it says first will be left to right, then from right to left, then left to right, then right to left. Correct? So to solve this question, we know na there are 2 traversals possible, BFS and DFS. Now we'll see with what approach we can solve the question. Okay, whether we can solve via both approaches or only one approach. But whenever we talk about zigzag level or traversal or anything related to level, I already told you in the previous video ki always go with the BFS approach. Although we can solve with the DFS also, but when it explicitly mentions ki traverse level order, then why you are going with DFS and storing all the levels in the array format and then printing it? It's better to go with BFS traversal. Okay, now if you are moving towards BFS traversal, and if you remember in the level wise what we did. In level wise traversal, we have saved our values 9, 20 and then 8, 15 and 7 like this. Can I say this? If you talk about the indexing, it is 0, 1 and 2. Correct? Means can I say even based indexing values are printed in the same order as expected. But odd based, this is expected in the reverse order. Correct? Yes. So we can simply print this and then iterate, and whatever are odd based indexing, we will reverse the array. Can I do that? Like this is a brute force approach I am saying. Okay. Even if you don't know how to optimize it, as of now if you know BFS traversal, definitely you can print the level order traversal and you can iterate on all the sublists and check if their index is odd, then reverse that sublist. Very easy. But why it is brute force? See, it is brute force because first though you have taken O of n space complexity and O of n time complexity to fill this sublist inside the list. Correct? Then further you will iterate on this to reverse. Correct? And also to reverse the array, you know na, O of n time complexity it will take. Correct? Although it won't be like n is a number of nodes. So in the level, in a single level, it won't be O of n for sure. But we always think about the worst case time complexity. And what will be the worst case? In the worst case, suppose you will end up reversing the largest size. And what will be the largest size? If you see, this is the largest size. And at max, if it is a full binary tree, definitely there will be a node for sure. Correct? Let's say. So how many number of nodes are there in the last one? Can I say 4? And what was the total number of nodes? 7. So can I say if it is a full binary tree in worst case, then last level would have stored n by 2 number of nodes. So reversing it is nearly O of n only, na? N by 2 means n, correct? So that is why reversal will further take O of n time complexity. So how can we optimize it further? Is there any further data structure which you are aware of? Ki, if it is about from left to right, we will keep on inserting like 1, 2, 3 and so on. And if it is about from right to left, then first time 1, then next time 2, then next time 3. Means what I did? From left to right, I inserted all the elements from back side. First one, then second, then third. But from right to left, I inserted like first, then from the front side 2, then from the front side 3. So can I say it has been reversed automatically without taking further O of n time complexity? Why? Because you have inserted every number from the starting position. To insert also O of 1 time complexity. So while insertion only, we have like adjusted the value such that it appears in a reverse order. Correct? So now I know one thing, what data structure it is. Can I say it is DQ? Yes, doubly ended queue, correct? Or else you can go with the linked list also. Why? Because linked list also allows us to insert at any position by taking O of 1 time complexity. Okay, so DQ or linked list works. Okay, done. Okay, so now the level or traversal we have already learnt in our previous video. I am not going to explain it again. I will definitely recommend you to watch that video first. Now in level or traversal, what we did, we wrote ki while our queue is not empty, first we have inserted our first root element in our queue. Remember? Yes. So this is our queue. So in the queue first we have inserted 3. Done. Now can I say like first we have to calculate the size of the node, because this node will go in my first sublist, correct? So I will calculate my size is equal to q dot size. Now here only I will create the array list, correct? But we have to create the DQ. Can I say that? Like we want this only as DQ, na? Outer one can be array list, but inner one I want DQ, so that I will insert the elements from front side and from back side depending on what index it is, correct? So I will make a new linked list. In Python and C++ you can make DQ, okay? With the help of linked list, type integer, I will make level is equal to new linked list. Now what we will do, we will run the for loop from int I is equal to 0, I less than size, correct, and I plus plus. Now inside this, what is our task? First we will pop the node. So we will pop the node is equal to q dot poll. We have popped the very first node. Now what we want to do with this? Can I say I want to add this, correct? I want to add this node in my level, which is a DQ, linked list or DQ, correct? So do you think we should simply add or we should check what index it is? Yes, we'll check what index it is. Okay, so there are two ways. Either start with, like here, start index with 0, and if it is even index, then insert in a DQ from last, and if it is odd, then insert from first. Or else you can make flag also. Okay, let's make it true initially, and now after popping you will check if your flag was true, then this is supposed to go from left to right, correct, in the same order, means we will insert from last. So what we will do, we will add level dot add last what node dot value, very simple, correct. Else what we will do, else we will add level dot add first, correct, first node dot value. Now what is the time? It's time for insertion of their childrens. Can I say? Means after popping of the node, we have inserted the node however it was supposed to be inserted. Means if initially flag is true, okay. So can I say I want this to insert like this? Suppose it was 1, 2, 3. So I want in the same order. So what I will do? I will insert 1 from the last, then 2 from the last, then 3 from the last. So it is as expected. Now what I will do, once this level is completed, can I say I will mark my flag to false, correct? Yes, I will mark my flag to false. But before that, once the node has been added, can I say ki it's time for their children to go in the queue? Yes, so that next time in the next level their children need to be entered, correct? So I'll check if my node dot left exists, correct? What we will do, in queue we will add node dot left. Very good. Similarly, if we have node dot right, what we will do, in queue we will add node dot right. That's it. And after coming out of this for loop, in our array, which is the external array, remember, in this we have to insert our level. So what we'll do, array dot add level. And now we have to make our flag false if it was true, true if it was false. So can I say flag is equal to not flag? So if currently the flag is true, it will become false because of not. And if the currently the flag is false, then because of not, it will become true. That's it. Now done. Now after coming outside, can I say ki yes, this answer we can return. So if you have already saw the previous video, which was level order traversal, these, like, if you will remove these two lines now, it's as it is. But it was about the reversal as per the levels. So that is why it is very important either to reverse, that will further take O of n. So O of n inside O of n, that will make it O of n square, which we don't want. So hence, to optimize it, we have inserted with the help of DQ or linked list data structure. That's it. Okay. So now if you talk about the time complexity, we are inserting each elements, each nodes in the queue only for one time. So space complexity will be O of n. Now talking about the time complexity also, it will be O of n. Why? Because whatever number of nodes you have inserted in the queue, that many number of nodes only you are popping it from here, correct? And now to add in the linked list, add first or add last, it takes O of 1 time complexity. Similarly, addition of left child and right child in the queue also takes O of 1. So in total, it's O of n time complexity also, which is the optimized approach. So let's write the code in the editor. Here is the code what we have discussed. First we'll create the list of list, which is the outer array. Now then we'll write the base case, key if root is null. Why? Because it says the minimum number of nodes can be 0. If it was given it is 1, then no need to write the base case in BFS. Remember, BFS, not in DFS. In DFS we keep on calling the function recursively, so it is very important to write the base case so that to stop the recursive call. Now after that we will make the queue. In the queue we'll offer root, and now initialize a flag with false. You can even initialize the index also with 0, and you can keep on switching it with 0, 1, 0, 1, 0, 1, okay? Anything will work. Now until we have elements in the queue, we'll calculate the size of the queue and we will run the for loop for that many size, because the for loop says or represents that many number of nodes inside that single level. Now if we have to insert the elements in that level, we have to create the level also. Earlier in the level or traversal, it was simple list, array list, but now because we have to insert from last and from first, which operations are only available in DQ or linked list. So in Java we have created linked list. You can either create DQ also, but in C++ and Python you can go with DQ. Now after creation of for loop, we will pop the node, and if our flag is true, we will insert in the, like, from the last position, or else we will insert from the first position. This is where the reversal was required. Okay, but we are not doing by taking O of n, we are doing it in just O of 1. Okay, now insert the left and right child, and after coming out of this for loop, which it says ki yes, now my level has all of its children, so now it's time to add that level in the outer array. So answer that add level, and now we have to flip the flag. So it was, if it was true, make it false, if it was false, make it true. And after coming outside, whatever is the answer, like array you have created with the levels, you just have to return this. So now let's run the code. Time and space complexity is O of n, which we have already discussed. Now let's submit this. Done. This is faster also. Why? Because we are not reversing the node inside the call, right? Okay. So this is the code in Java. Here is a code in C++ with the similar approach what we have discussed, and here is a code in Python with a similar approach if you are from Python background. So this was your BFS approach for this problem. Now suppose, because you are a fresher, as a beginner you should think about all the different approaches. What if interviewer asks you ki is it possible or not to do with DFS? Okay, is it possible or not? So to answer this question, we have already discussed about this in our BFS level order traversal. Okay, so if you have watched that video, you definitely know the answer ki yes, we can do it. But although the question mentions it as a level order traversal, so it's always preferable to go with BFS. But it is possible with DFS also. And how? That we have already discussed ki start from the root, okay, and let's suppose this is a 0 level. Why we are doing so? Because DFS says ki keep on going to one child. So if you decide to go with a left child, so you will go here, again you will go here, you will not go here. So coming back, how you will decide ki 9 and 20 belongs to the same family? For that you will assign them a variable that is called level. So we will assign them a variable, let's say level. So for this level 0. Now going towards left child and right child, we'll simply update their level with parent level plus 1. So similarly, parent level plus 1 means 1. Now again we will go to the child of 9 and we will again say parent level, which is 1 plus 1 to 8, which is 2. Correct? Now we'll go back and now again from here this level 0. So we will do level plus 1, which is again 1. Now who will remember ki what is the level of this? That stack calls. So first initially you will insert for function 3, level was 0. Now this will call its left child. So for function 9, level 1. Similarly function 8, level 2. Now from 8 we will call null. So we will return. Why? Because in DFS function where we have root and we have level, for sure we would have added our base case ki what if our root is null. So if our root is null, return from there, return. Correct? So now this call will get returned. Now we'll go for functions like 8's right. Again there is nothing. So null will also get returned. Back to this. Now its left also got returned, right also got returned. So can I write here ki DFS for left root dot left level plus 1? Yes. Similarly DFS root dot right level plus 1. Now after this line of code I can say ki for 8 left and right both has been returned. So for sure it will also get returned. So it will also get removed from the stack call. Correct? Now we'll go back on 9. Now we'll call for 9 dot right function 9 dot right, which is null. Again this will also get removed. Correct? So 9's left already returned because of 8 and 9's right also returned. So now I can go for like left return, right return. So can I say at final it will also get returned. So 9 which was 3's left will get returned. So 9 will get removed from the function call. Okay. Now we will go for 3's right. So this function has remembered its level na 0. So when we will go for 3's right, so it will say parent's level, which is 0 plus 1. So function 20 and 1. So that's what I said ki stack calls will remember the level which was assigned to it. So now we'll go for 20. Now again for further 20 left call. So function 15 and level of 20, which is 1 plus 1 2. Similarly 15's left, which is function null will get returned. So we will remove it. Similarly for 15's right also returned because of null. Now left returned, right returned. So function for 15 will also get returned to 20. So now this call will get removed from the stack call. Done. Now from 20 we'll go towards right side for 7. So we will add function 7. What was the level of parent? This function call has remembered it 1. So total 1 plus 1 2. Now again we'll go for 7's left, 7's right. We will find nothing. Returned. Now this left has been returned, right has been returned. So 7 will also get returned. So 7 will get returned to 20. So 7 function will get removed from the stack call. Done. Now 20's left also has been returned, right also has been returned. So now 20 will also get returned. So 20 will get returned to this, and now 20 call will also get removed from the stack. Now for 3, left has been returned, right has been returned, left has been returned, right has been returned. Now 3 will also get returned. So 3 will also get returned from the function. Now the stack will become empty, and now this is what we had. But we have not stored it anywhere. Means at every function call you saw na, we had level. So why not to use it? So if we can say if root is not null, so before going to children, let's do one thing. What? Let's save, like you have a array list. So let's create a sublist in the list and let's save that node value with that index. And what is the index? That is nothing but level. Can I say that? So what I will do here we'll write key first. So if level is equal to array dot size, then create a new, means array dot add new array list or linked list. So it is about DQ, so let's add linked list. Why? Because here in this case, if you remember, in this case we have to, like, there is a need to reverse, which we don't want to, because it is taking O of extra O of and time complexity. So we want to use what? DQ or linked list, so that we can add from last or add from first. So what we are doing here now, initially before traversing, you don't know how many levels will be there, correct? So initially the size of array is 0 and level is also 0. Can I say one extra linked list or DQ here? So size is 0, level is 0, so yes. So I'll create, done. Now we'll go for left and right child. But before putting this 9 and 20 in some DQ, there should be some, like, one more extra for it, linked list or DQ. Yes. So how we can check? Level 1 and size is already 1. So we want one more. So similarly, we have written if level is equal to array size, then there is a need to add that extra DQ or linked list, which will act as a sublist, correct? In level or traversal we saw that. Okay, done. Now we have inserted a new linked list here, correct? But we want a reference also, so that we can be able to insert these values, node values, inside this linked list or DQ, correct? Now here we'll create linked list because we want a reference, so linked list of type integer. Okay, now let's name it current is equal to answer dot get, can I say level, because we have already inserted now. Here by this line we have already inserted a new linked list. Now we want a reference with this current node, so that with the help of this current we can insert the values, but we have to typecast this into linked list. Okay, so here we will typecast, let's say linked list, okay, of type integer. That we'll see in the code more clearly. Okay, now done. Now we have current. Now what is the task? What is the level? Initially level is 0. So can I say if my level is even, I will insert in this current from last side, means current dot add values from last, so add last. Now next time if level is 1, if it is odd, then current dot add first, what? Node dot value. So let's move this piece of code here. Okay, now what we will write, key if level modulo 2 is equal to 0. So this is even. So if it is even, means current dot add last, what? Node dot value, correct? So in this format if you will add, so it will be 1, 2, 3. Okay, else if it is odd, then what we'll do? Current dot add first, what we will add? Node dot value. Now if you will add like this, so it will happen like keep first one will get added. Now add first, so 1 will get moved ahead, and here 2. Now to add 3, 3. So it is by default in reversed order. So this is how, using the DFS, we have first check if it is null or not. Then we have checked if level matches with current size, then there is a need to insert a new linked list. Done. Now in that new linked list, we need a reference, so that with the help of that reference name, which is current in this case, we will be able to put the nodes in it. Now it is about how do we put, because if you simply put in the level, then you have to reverse it whenever it is about the odd levels, correct? But we don't want to reverse, so that we can save that extra time complexity, and that is why we have used this linked list or DQ instead of simple array list. So I hope you understood. So this is how, with the help of DFS, now after coming outside, you can simply return your array or answer whatever you have created outside, and that's it. Talking about the time complexity, we have visited every node only at once. So O of n time complexity. Space also, we have saved all the function calls. Can I say all the function calls? So here all the function calls at most one time. So in the worst case also it is O of n. Okay, O of n. Why I said O of n in the worst case? Because if you saw now, first you inserted 3, then you inserted 9, then you inserted 8, then you removed 8, correct? Then you removed 9, then you went on 20, then you went on 15, then you removed 15, correct? Then you went on 7, then you removed 7, 20, and then removed 3. So at max you have used only 3. Can I say that is nothing but number of levels. Okay, but why in worst case? Because it might happen ki there is continuous, we have child, correct? There are only 3 childs and rest all children are here. Then to in worst case you will keep on inserting this until you get returned back, correct? So in the worst case, it will save all that calls in the stack. So hence O of n space complexity. Okay, so time complexity wise and space complexity wise both are similar only, but it's more preferable ki if it is about level order traversal, please go with the BFS traversal using Curita structure. But it's not like it is not possible with DFS. That's why I have discussed both DFS and BFS code in this video. Now let's write this same code in the code editor. So here is the code what we have discussed in DFS. First we'll create that outer answer. Now we'll call the DFS function which we will create with the level 0, and at the end we will return this answer because we are calling this DFS function only to fill that outer answer. Now we will call it base case if root is null return, otherwise if level is equal to answer size, every time we will create the new linked list or DQ and insert in that outer array list. Okay, now we want a reference by typecasting, done. Now if your level is even, then add from last, means we want normal simple level without reverse. But if it is odd, then add from first, because so that it will maintain the nodes in the reverse order without actually reversing it. That's it. And now we will go for the left call and right call. Okay, so now if you want to see the dry run of it now, let's do it here. Okay, so at first we will be at 3, so we will create first this, and now as a size is 0, so we will insert one linked list here or DQ here, done. Now we will insert 3, correct? Now we will go at 9. Level is 1, size is 1, again we will create one more extra. So we will create one more extra DQ. Now we will insert 9. Now we will go at children 8, level is 2, size is 2, so we will create one more and insert 8. That's it. Now we will go back at 9, again we will go back at 3. Now we will go at 20. What is the level of 20? 1. Size is 3, level is 1. Do we need to insert a new? No. So what we will do, we will simply get from here we will simply get this. So that's why we have written this extra line of code. Key here we have not created, but we want a reference, correct? So hence we will go and check in answer array with the help of level. We will get that reference and we'll call it current. Now in this current we have to insert 20, but how we will insert that? Level will help. So level is odd, so we have to insert from first. So what will happen? 9 will get shifted here and we'll insert 20. So by default it is reversed. Now we'll go on 15. Level is 2. Size is 3. Do we need to insert new linked list? No. Get the reference. Okay. Now as a level is even, so add from last. So from after 8, 15 will get added. Now we'll go return back. Now come here 7. Level 2. Do we need to create new because the size is 3? No. We will only create when the size and level both matches. Okay. No, will not create. Get the reference. And as the level is even, so add from last. So 7 will get added here. So this is how BFS will do. BFS will create all the levels and then going back and again moving ahead, depending on the levels, it will keep on inserting the nodes in the different levels. But when we are doing with BFS, it will first create this and try to fill this level with all the nodes. Second time it will create this, try to fill all the nodes here, then only create the next level. But DFS don't do so. Okay, so this was your complete code. That's what we are doing here and we'll keep on moving. So I hope you understood the dry run also, the time and space complexity and the exact difference between the DFS and the BFS. So if yes, then let's try to submit this code. And this was your Java code, guys. If you understood, here is your C++ code if you're from C++ background, and here is your Python code if you're from Python background. So that's it. If you understood, definitely we can go in the sheet and mark the next question as done. If you did this or if you understood this, please do hit the like button and do let me know in the comment section how you have liked and how you have understood the video. So that's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. So then keep learning, take care of yourself and your family.